Thank you all for joining us today for this talk on Microsoft Information Protection MIP SDK. My name is Hamad Rajoub. I'm a Director of Product Marketing and I focus on compliance ecosystem. For today's agenda, I'm going to set a quick context on compliance ecosystem and then pass it to Arvind to walk you through all the latest and greatest on MIP SDK, including a real-world customer scenario and a demo. This is going to be exciting. Let's start with why first. We know that 91% of enterprise customers have multi-cloud strategy. Our customers are looking to reason over their entire multi-cloud data landscape and not just Microsoft data. Our customers want and need to be able to integrate Microsoft compliance value, including information protection and governance, insider risk management, discover and respond, as well as compliance management within their existing security, compliance, and identity-related investments. That's why we're building our compliance platform to be extensible and solving for our customers' multi-cloud reality. To that end, we see extensibility as a horizontal capability and you all developers as a key enabler of this across all compliance pillars. Now let's talk about our key investment areas. To enable extensibility and compliance beyond Microsoft, our investments are spread across three key dimensions. Number one, multi-cloud data access. To enable our customers to reason over their entire data landscape, including Microsoft and non-Microsoft systems, we have extended our data connector platform by enabling ready-to-use partner-built connectors for a variety of external sources, such as Slack, Zoom, WhatsApp, Bloomberg Chat, etc. For in-place compliance value, spanning across structured and unstructured data, we have Azure Purview. This covers multiple cloud data repositories such as AWS S3 buckets, Oracle, and SAP, to name a few. Number two, APIs and SDKs for integration. To enable system-level integrations, as well as enabling compliance in the flow of work, we are doubling down on our investments in APIs. We have a number of Microsoft Graph APIs, and we also have, of course, Microsoft Information Protection MIP SDK. And this space is constantly growing. Number three, built-in customizations. To meet unique needs of our customers, we are also investing in enabling built-in customizations. Power Automate is such a powerful tool to automate and create custom workflows, no pun intended. And this happens from within compliance solutions such as insider risk management, as well as communication compliance. We have a robust compliance partner ecosystem with 200 plus partners and growing. These partners have built a number of integrations across compliance products, providing broad coverage across devices, apps, cloud services, as well as on-premises systems. MIP has been part of Microsoft Intelligent Security Association, or MISA, since the association began in 2018. This year, we have further expanded MISA program to include 5 additional Microsoft compliance products, including Microsoft Information Governance, Advanced E-Discovery, Data Loss Prevention, Insider Risk Management, as well as Compliance Management. We have a really rich surface area for APIs and SDKs. We have announced a number of Microsoft Graph APIs over the last few months for compliance scenarios, including Teams DLP, Teams Export, and Advanced E-Discovery. There are, of course, many more to come. All of these APIs are part of a robust and well-established Microsoft Graph API ecosystem. This spans across trillions of nodes and hundreds of billions of requests per month. Today's focus, however, is on MIP SDK. So without further ado, I will pass it to Arvind to walk us through all things MIP. Arvind, please take it away. Thank you.
Hi, everybody, and welcome to Build. My name is Arvind Chandaka. I'm a program manager in the Cloud and AI Security Engineering team, focusing on Azure Information Protection and Azure Purview. Welcome to this session on developing compliance-powered line of business applications using Microsoft Information Protection SDK. For the agenda in this session, we're going to go into the introduction a little bit here, and then we're going to talk a little bit more about Microsoft Information Protection and the suite of capabilities along with the SDK. And then finally, we'll cover some customer scenarios along with a demo with some code. Let's first talk about the Microsoft Information Protection suite of capabilities in M365. Microsoft Information Protection is a suite of capabilities in M365 for protecting your sensitive information worker data. One of the core components here is the usage of sensitivity labels. You can use sensitivity labels to denote the sensitivity of certain kinds of information worker data that is important for a corporation. You can denote information as public, general, confidential, highly confidential, or whatever the corporation chooses to use to indicate that level of sensitivity. You can also use protection settings, visual markings, and many more different applications within this paradigm. You can see the label configuration of these sensitivity labels in Security and Compliance Center. Here, you could essentially create the different kinds of labels for your enterprise, and you can set it up using the protection settings you would like to see. As an example, you could set the different kinds of permissions, usage rights, as well as the scope of your different kinds of labels. Let's transition over to talking about the Microsoft Information Protection Software Development Kit, or the MIP SDK. The MIP SDK can be used to extrapolate information protection capabilities to your line of business applications and your partner applications. We have a very rich ecosystem using the MIP SDK with almost 200 plus partners, many of which you could see on the screen here, as well as 20 product integrations and usage over 5 different industry verticals. The Microsoft Information Protection SDK is a cross-platform SDK. You can use it on Windows, Android, iOS, macOS, and different flavors of Linux, including CentOS, Debian, and Ubuntu. You can also create that MIP SDK using 2 different languages, such as C++ and .NET. We also have the availability to use a Java wrapper. In addition to this, we also have a new Graph API endpoint we are working on that is currently in public preview. The MIP SDK is important because you can extend classification protection and labeling capabilities to the different line of business applications you may have. You can also broaden the reach of these information capabilities as a result and meet a lot of your different customer and business use cases overall. The Microsoft Information Protection SDK uses 3 different SDKs: the Protection SDK, the Policy SDK, and the File SDK. The Protection SDK essentially takes in plain text and outputs ciphertext, or you can input ciphertext and receive plain text. Essentially, it gives the developer the flexibility to use rights enforcement in their applications. The Policy SDK doesn't actually do anything. What it actually does is exposes the different kinds of label actions that you can go ahead and implement. Finally, we have the File SDK, which is an amalgam of both the Protection SDK as well as the Policy SDK. And you can use this essentially to reason over files in order to perform label actions or protection actions. This is what is most commonly used by partners and other customers who are building out line of business applications. And we'll go into this a little bit deeper in our demo. Let's go a little deeper into the File SDK. The File SDK abstracts functionality of other SDKs to file-specific operations. You can apply, update, or remove labels and protections, and you can use a variety of functions including get label, get protection, set label, remove label, and more. It essentially takes in files and output files, thereby reasoning over them and applying these different kinds of label actions. These are used by different scanning applications, line of business applications protecting file outputs, apps that are generating full file output, and much more. Let's talk about the Policy SDK next. The Policy SDK doesn't actually do anything in your application in terms of actions. What it will do is expose the actions that you need to take to implement within your application. So if you pass in label information, the state of the file, you'll basically get an output that is the list of actions that your app needs to implement. Some of these functions include apply metadata, remove protection, apply watermark, and these actions are basically discrete parts of a document that you could take using the Policy SDK. The Protection SDK handles RMS protection internals. It can apply, update, or remove labels and protection. Some of the functions include get label, get protection, set label, remove label, and more. It essentially takes in buffers of bytes and also outputs buffers of bytes. It's used by applications that directly perform encryption or decryption of streams or data. and you as the developer are responsible for parsing through the file formats and decrypting or encrypting the necessary bits. Let's talk next about the different SDK classes. Mipcontext stores application info, storage configuration, and more. The MIP profile is basically the root class of all SDK operations. And with the engine, this is now the interface for all operations that need to be done in the context of an identity. So here is where you'll see the implementation of the auth delegate. Finally, we have the handler, which is an API-specific class for specialized operations. And we'll go into detail of each of these in just a second. Let's start by talking a little bit more about each of these classes. First, with Mipcontext. You can use Mipcontext to initialize the profile. This stores information on application ID, name, and version. You can set the path for local cache, such as logs, the cache storage database, which would hold your policies and licenses. This allows the developer to override logging and telemetry settings to their needs. Remember, you can only use one Mipcontext per process. So here we actually have an example of what the Mipcontext and even profile looks like. You could basically set it up such that you could use the Mipcontext and define it based on passing in the application info and the MIP data. And then ultimately, you could set up a profile by using this context. Again, remember, only one Mipcontext per process. Let's now talk about the engine class. This is a class for all user-specific operations. As an example, you can call the auth delegate class to fetch an OAuth2 token and use it in this particular context. Engines may be cached and loaded or created, and you can enable control of cloud endpoints such as the sovereign endpoint, commercial endpoint, or ADRMS endpoint. You can enable the delegation of operations and set label filters and fetch labels or even protection templates. Finally, we have the handler class, which is the class for all SDK-specific operations. You can add this to an existing engine class and expose methods to notify the audit pipeline. You can use other methods such as get, apply, remove labels, and protections. Here's where you can actually do many of these kinds of applications that is representative of the Microsoft Information Protection SDK. Let's switch over from the PowerPoint to the demo really quick to demonstrate how this looks in an actual sample or environment. Before we go into this a little deeper, let's just cover what a customer scenario would look like here. In this case, a customer scenario where HR is basically working on the payroll of individual employees in their company and collecting this sensitive information would be a key use case to think about. If that information for some reason needs to be shared with finance or other departments within the company, that would basically need to be protected on download when that information is exported. This is the use case we're going to be taking a look at. This is an ASP.NET application where we go through and have essentially the sensitivity labels that you can go ahead and click and basically download the information of employee IDs, employee names, and their relevant salaries. The export will essentially be an Excel file that will then be protected and will be protected using the label of your choosing. Here right now, I'm sitting in the file API.class file, and we're going to go ahead and actually run the application. When we run the application, we'll actually see the application now running in the browser, and you'll see it's this ASP.NET application. And here in the middle of the screen, you could see that we could choose the different kinds of labels that we'd like to select. In this case, in our taxonomy, we have the public label, the personal label, the general label, confidential, and highly confidential, with the following sublabels of recipients only, all employees, and anyone not protected. If you look below, you'll see a mini table filled with employee IDs, the respective names of the employees and the salary that they make at the company. Now, if I wanted to go ahead and demonstrate this example, what I could do is I know that this information should be classified as confidential all employees. So I can go ahead and select that. When I go ahead and select that, you can see here that we are trying to, the screen changes to adapt to that confidential all employees label. Now I can go ahead and select download, and we'll see basically that we can go ahead and download this Excel file that should be protected on download. And here we'll basically see the set of information we were able to see in the table, but in Excel format. You can also see that the information is classified as confidential all employees, both from the banner at the top along with the label that is applied here. So we have successfully done or performed this use case of actually downloading this information and having it protected at the time of use. How did we go about actually building this out? Well, let's go back to the code to find out a little bit more. Going back to the code, let's start with this main file, which we call the File API class file. This is where a lot of the concepts we talked about in the PowerPoint are included, such as the Mipcontext, the profile, engine, handler, and much more. We could see here that at the beginning of the File API, we have several different private variables that need to be instantiated and created. The constructor for the File API object, like we mentioned in the Mipcontext field, needs to have the client ID representing that application, the application name, as well as the claims principal that represents the user. You can see here in the constructor that we go ahead and assign application ID with client ID, application name with application name, application version with application version. You'll notice here in the next line that we start initializing the auth delegate here as well. And at this point, I'm actually going to jump over to the auth delegate implementation class here in the Solution Explorer. If you remember, the auth delegate is important for using basically, or is important for obtaining the OAuth2 token in order to use this particular application in conjunction with your other services. It essentially enables your ID and your identity. From this particular implementation, you could see that the IAuth delegate class is being created with several different private variables. Many of these app settings are being pulled from the web configuration file that we pre-populated with the necessary AAD instance, tenant, client ID, and more. Here is actually where you go ahead and implement your necessary authentication library to obtain an OAuth2 token. Remember, the developer has the flexibility to choose whatever platform or whatever library they choose to do so, as long as it outputs an OAuth2 token. The implementation and its overall flexibility is left entirely up to the developer themselves. So you don't necessarily need to use the example here for your applications as well. Here, however, we are using the Microsoft Authentication Library, or MSAL. And you could see here, basically, it is being run and used in order to get the access token on behalf of the user. Now let's head back to the File API class. We just finished initializing the new auth delegate. Remember, you don't actually use the auth delegate until much later in the engine itself, where you basically have user-defined actions and operations that take place. However, we do end up here calling the functions for the create file profile as well as create file engine. Let's check out those functions next. Here we have the create file profile function. And here we basically create this new file profile object and then store it. And as you could see, we could basically use the create Mipcontext in order to create that Mipcontext mentioned earlier in the sample, and then essentially use it as part of the file profile settings. You can then load the file profile and use this to initialize your profile. Next, you have the create file engine. Here, we basically initialize a new iFile engine using the provided username, a custom client data string, and locale. You can input in these different pieces in order to create the necessary engine settings, and that is listed here in the function for file engine settings, including the username, the auth delegate, client data, and more. Finally, we have the create file handler function. And here we create the iFile handler object for the specified file or stream. So you can input these different components in, and essentially we'll use the create file handler async function in order to create those respective handlers. At the bottom here, after all of those primary classes that we've discussed in the presentation, we have some of the other actions that you could take with the labels, such as apply label, which you could use in the handler. You also have the list all labels function here. And here you could see basically the label ID, description, sensitivity, and more, and basically create a tree model out of the taxonomy that you have created in Security and Compliance Center. So now we could see this class file, which is the default.aspx class file. We have here some of the different kinds of actions that are more relevant to our particular application and its usage. Remember that one of the things we wanted to do in this scenario was to be able to select a particular kind of label to apply to the file such that it will be included on the file when it is downloaded. So here we start with the Populate Labels area, where we're able to see basically the different kinds of labels, their names, and so on, and basically have a tree view in order to view them. You can then also use the web client to read the data from the web service, deserialize and store and bind them to the grid view. And then you also have the piece here for the button download click. And this is essentially where we're able to click that download button after having selected a particular label to apply. And thus we'll see the workflow here that runs through and actually results in the label controller seeing that the label has been applied, and then resulting in a result, which is that file that is downloaded with your confidential all employees label. This concludes our demo and our session on developing compliance-powered line of business applications with the MIP SDK. We hope you learned something new, and we hope you go ahead and implement this for your line of business applications as well. For further resources, be sure to check out our blog, binaries, NuGet packages, our docs, samples, and even our graph endpoint that we are working on in public preview. Thanks again, and enjoy the rest of Build.